In this video, I'm going to show you how to compute cross product by using properties of standard unit vectors. So here is something that is actually very easy to remember. If you look at a little diagram I have here, where vectors I, j, and k are depicted, and remember these are unit vectors with a length of 1. And just remember that this would be like x-axis, y-axis, z-axis, right? So what you need to remember is that if you go counterclockwise from I to j and then to k and then back to I, so if I draw this, this would be something like this, where I go like this and here and here. Then what I would remember, if I just had this diagram, then I would say if I cross I with j, I should get k. See, this is where this comes from. Now, go use the diagram, and remember, you have to move counterclockwise. So if you cross j with k, that should give you I. It's very easy to verify that, by the way. So you can just verify that using the definition. So that I and j is k, j and k is I. Okay, crossed. Now, what about k with I? So k crossed with I would give you j. Okay, so you don't really have to remember anything. You just have to draw this little diagram, and that's it. Now, what you also need to remember is that if you change order, the cross product switches sign. So cross product is not commutative. So j cross with I is actually not going to be k. All I'm doing is just switching them around, and this is going to be negative k. Or if you look at the diagram, and if you look at the diagram and see that to get from j to I and then get k, you're actually going clockwise, then that's why it's going to be negative. Okay, and then j cross with k is I, so k cross with j would be negative I. And then same thing here, k cross with I is j, so that if you switch them, I cross with k equals negative j. So I just rewrote what you see right here, just to explain to you how you can come up with it without actually memorizing any formulas. Now, another property that you need to complete these kinds of exercises that we're going to look in a second, you also need to know that a cross product of any vector with itself is always a zero vector. So no matter which vector you cross with itself gives you zero vector. The reason, by the way, why that happens, if you remember determinants, if you know anything about determinants, if you cross two vectors, then the second and the third row, if they're the same or even actually proportional to each other, the determinant is equal to 0. So this is one of those properties of determinants. If two rows or two columns, doesn't matter, are proportionate, the answer is 0. So that's why a cross product of a vector with itself is always going to be 0. Now let's go ahead and see if we can simplify this expression. So first, I actually need to use the distributive law here, so which works with cross product. So I am going to get 3j cross with I minus, now 3 times 2, that's 6, j cross with k. So I just need to remember what this is. Okay, so let me show you again. So this is like I, this is j, this is k. And I just want to remember that I am moving counterclockwise. Then that's going to be a plus. So what is j cross with I? Well, in order to get from j to I, you're actually going which way? You're going clockwise. So you don't get a k, you get negative k. So this would be negative 3k. Now, how about j cross with k? Okay, so j cross with k, that I'm going actually counterclockwise, so I'll get a positive I. So this would be negative 6i. Now, if you want to, you can reorder them, and usually that's what they prefer, to put I first, then j, which is missing here, and then k last. But that's the answer.